So in the lecture notes section, this is actually, these notes are coming from 10.3. All right, just to show where this is coming from. In the lectures notes section, this is under the set of notes for section 10.3, and it talks about vectors. And here's some basic terminology when you talk about vectors. A vector has to be represented by two dimensions: its magnitude and its direction. A scalar is a magnitude, for example, 45 pounds. 45 pounds is a magnitude. A magnitude could also be like miles per hour. A magnitude could be a weight, right? 45 pounds. So the vector has both a magnitude and a direction. So here's an example. 50 miles per hour east. 50 miles per hour, that's your magnitude, and east is your direction. There's also an example of a vector given with the drawing. The magnitude is 10 pounds and the direction is 30 degrees, right? That's also a vector quantity. Vectors are represented in boldface with an arrow over the letters, but not so much in this textbook. We represent vectors by using like the greater than and the less than brackets. So here's like the setup for a vector. And all vectors stem from the origin. So here's just an example. Okay, let's just say that we have, I'm just going to go out to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's say I have the point 3, 1, and let's say 4, 4. So let's just say I have this vector. But this vector has two endpoints, right? 3, 1, and 4, 4. Whenever we denote or talk about vectors, all of these vectors stem from the origin. So the way to shift this vector to the origin, I'm simply going to take my x coordinates, 4 minus 3, is 1, and 4 minus 1 is 3. Right. So I basically took my x coordinates. 4 minus 3 is where I get 1. 4 minus 1 is where I get 3. But for a vector, you're going to see like the greater than and less than signs. So that means that from my origin, I'm going to go over 1 and up 3. So these two, and this is not drawn to scale by a long shot. My graph is like crooked, but these vectors have the same magnitude, which would be length, and they have the same direction, which would be the angle measure. The difference is for this vector, we express it by simply its endpoints. So just like we talked about angles, all of our angles are in standard position. When you talk about a vector, all of these vectors stem from the origin, and they're all written out with angle brackets, right? And they stem from the center to denote that they're vectors. All right, so that's just a vector example. So all of the vectors we're dealing with from this point forward, they're going to be written with this notation, right, with the angle brackets, and they're going to stem from the origin. So we call them position vectors. A position vector U with endpoints A comma B is written as a boldface U, and is written with the angle brackets A comma B. Right? So anytime you see coordinates given with an angle bracket, that represents a vector. A is called the horizontal vector. B is called the vertical component. All right, so we got a horizontal component for our vector and a vertical component for our vector. Now notice a lot of this stuff is going to look similar. So the absolute value of U, that's vector U, that's actually Pythagorean theorem. The square root of A squared plus B squared. That gives us our magnitude or our length. We can also find the direction by using the formula to find theta, which is the arctangent of B over A is equal to theta. Right? So these are directly similar to polar form where you have R, right, which was the square root of X squared plus Y squared. And then you had an angle measure, right? And that angle measure was the arctangent of B over A that gave us our angle measure, right? So those same two components in this instance give us our magnitude and our direction. All right, so let's take a look at homework 4.6. All right, so the first couple of problems, they want us to graph. All right, so like for problem number 1, it says graph the vector V that goes from the origin to the given point, then write V in component form, right? So component form is just using those angle brackets. So I want to just graph this -5, 4. So now here's the thing. You want to start first at the origin. And then for my problem, I'm going to go 5 spaces to the left. And I'm going to go up 4. Right. To write it in component form, I'm going to use the angle brackets. I thought I generated a new problem. So I'm going to use the less than -5, 4 with the greater than. It won't let me submit it because I already submitted it. But you should graph, start at the origin, and then when you write it in component form, you want to make sure you use your angle brackets. Now we can also write vectors in I and J form. Let me just go down. So this says a unit vector is a vector that has a magnitude of 1. 2 very useful vectors are I and J forms of vectors. Okay, so we don't necessarily deal with unit vectors too much that have a magnitude of 1. But this box says I and J forms of vector units. You can take the vector V which has the horizontal component A and the vertical component B. And you can write it in the I and J form. You can actually write that as AI plus BJ, right? And then vice versa. If you're given the I and J forms of a unit vector, you can write it in component form, right? Just simply take away the I and the J, add a comma, and use the angle brackets. Okay. We can also perform operations with vectors. We can add, we can multiply, and we can subtract. So here, basically the formulas, it says that A comma B, so notice that's a vector, plus C comma D. You can add those two by adding the horizontal components and then adding the vertical components. This is actually a formula B, and it's multiplying a vector by a scalar. So if you have K times A comma B, you can actually distribute K, and you can write that as K times A comma K times B. Right? And that's called multiplying a vector by a scalar quantity. There are also formulas to subtract. So it says A comma B minus C comma D. You can subtract your horizontal components and you can subtract your vertical components. So let's take a look at an example. So here's an example. It says let U equal to negative 2 comma 1 and B equal to 4 comma 3. And we're asked to find each of the following: U plus V, negative 2U, and 4U minus 3V. So to find the first one, U plus V, we can simply add our horizontal components, right? Negative 2 plus 4 is positive 2. We can add our vertical components. 1 plus 3 is 4. For B, we want negative 2 times U. So negative 2 is our scalar. Our vector U has the components negative 2 comma 1, and we can distribute. Negative 2 times negative 2 is positive 4, and negative 2 times positive 1 is negative 2. And then in the last one, for C, 4U minus 3V, we can actually multiply vector U by 4, multiply vector V by 3, and then subtract our vertical and our horizontal components. Let me see if I can remember, but there is a way we can do this on the calculator. And I believe it's with the brackets that are above the parentheses. So let me try the first one. So I'm going to use, they're not angle brackets, but they're these curly braces. So if I use negative 2 comma 1 plus 4 comma 3, it's going to add them up for me to get 2 comma 4. If I wanted to do problem number B, negative 2 times U, I can put in negative 2. That's negative 2. And notice I'm using the curly braces, right? And I can put in negative 2 comma 1 in my curly brace, and I have 4 comma negative 2. And I can do the same thing for C. can put in 4 times, so notice I'm using curly brackets now. I'm not using these parentheses. I can put in vector u, which is -2, 1. Close off that vector minus 3 times vector b, which is 4, 3. And I get -20, -5. So any questions on performing vector operations? The only thing you cannot do is multiply. So we're going to take a look at that in a second. Right, referring back to the all exam formula sheet, I believe there are some formulas for vector operations, right? Exact same formulas that were on the slide. Okay, so let's take a look at like problem number 3. It says given that u is 2I plus j, so they're writing the vector in I and j form, and v is equal to 2I plus 3j, they want us to sketch u minus v. So what I'm going to do is I'm going to use a calculator. I am going to write out u minus v, but I'm going to take it out of the I and j form. So u is actually 2, 1, right? Because the coefficient of I is 2. The coefficient of j is 1. Minus 2, 3, right? So I'm taking away the I and j and just writing out the coefficients. So notice I'm using the curly brackets. So that's 2, 3. And I get the point 0, -2. So I'm just going to sketch that out as a vector. So I'm going to initially plot it at the origin. I'm going to plot the point 0, -2. So since x is 0, I don't move to the left, I don't move to the right. I'm going to stay on the y-axis, but I'm going to go down 2. Right? And that is our vector. So the first one, it kind of just gave us the endpoint for the vector. For problem number 3, they gave us I and j form, and they wanted us to subtract and then plot the vector. All right, now for problems number 4 and 5. 4 says use the given magnitude. So the given magnitude here would be 3. And the direction, so the direction is 135 degrees. In standard position to write the vector in component form. So component form would be, well, in this case, they're using the I and they're using the j suffix. Okay. So let's talk about how we can take the magnitude and the direction and write out component form. We do that by use of some formulas. And here are the formulas. So horizontal and vector and vertical components. The horizontal and vertical components respectively of a vector u having magnitude u. So even though this looks like an absolute value, this is actually the magnitude of a vector. And a direction angle theta are given. A, which is the horizontal component, that's equal to the magnitude of vector u times the cosine of theta. B, which is the vertical component, is equal to the magnitude of vector u times the sine of the direction angle. So these are the two formulas we're going to use to write in horizontal and vertical component form. So I'm going to go back to number 4. So the magnitude of vector v is 3, and theta is equal to 135. So this is 4.6, number 4. Write in component form. So the magnitude of vector v is 3, and the angle measure is equal to 135 degrees. So we have A is equal to the magnitude of vector v times the cosine of theta, and B, which is the vertical component, that's equal to the magnitude of vector v times the sine of theta. So to find the horizontal component A, that's going to equal to 3 times the cosine of 135 degrees. So if I use the unit circle or either the unit circle function values chart to find the cosine of 135 degrees, that is going to give us negative square root of 2 over 2, right? So the cosine, which is the x-coordinate of 135 degrees, is negative square root of 2 over 2. So if I multiply those two things together, I get negative 3 square root of 2 over 2. So that is my horizontal component. I can find B, right? The magnitude of vector V is 3 times the sine of 135 degrees. So if we take a look back at the unit circle function of values, the sine of 135 degrees is square root of 2 over 2. So combining those, I get positive 3 square root of 2 over 2. So we have negative 3 square root of 2 over 2, comma 3 square root of 2 over 2. All right, so we have negative 3 square root of 2 over 2. And they've just written it out in I and J form. So this can also be written as all right, so they're writing it out in I and J form for number 4. Problem number 6 would work in an identical manner. So I'm going to try something. I didn't try this earlier at home, but you could use these functions in the calculator under angle, because they don't say exact value. So I'm just going to see what's going to happen with number 5, right? That vertical component, that's actually the same thing as finding x, right? Because I'm given an r and a theta, right? R would be 5. Theta would be 60. So I get like 2.5. And then if I find my vertical component, I'm going to go back in the angle. I'm going to look at the A function. I got to put in an R and a theta. So I'm going to put in a 5, comma 60. So I'm going to just see if it's going to accept that. So my horizontal component is 2.5. And my vertical component is 4.33. And it will accept it. All right. So I'm assuming that if it does not say answer exactly, you can use the calculator function. So even though we did number 4, right, by, the exact values, let me just see if it'll take the decimal answer. So I'm going to try number 4 using the calculator just to see if it'll work out. So I'm going to go back in the angle. For the horizontal component, I'm using the 7 function. So R is 3. Theta is 135. So it's not going to give me the square root. It's going to give me like the decimal approximation. I'm going to go back in the angle. I'm going to use the A function to find the vertical component. I'm going to use 3 and 135. So let's try negative 2.12 and 2.12 positive. And it accepted it. Okay. All right. So the question's about 4 and 5. Okay, the horizontal and vertical components are the same as using that 7th and the 8th function. Okay, problem number 6 says let V equal to negative I plus 5j. Find a vector that is twice the length and in the opposite direction. So what I want to do here is I actually want to take this vector, I want to multiply it by negative 2. I'm multiplying it by 2 because it's going to give me a vector twice as big. And since it's in the opposite direction, I want to multiply that by negative. So I believe I can use the calculator for that. So I'm going to take the value negative 2, and I'm going to multiply it by my vector. So I'm going to take my coefficients. So the coefficient for negative I is negative 1. The coefficient for 5j is 5. And I use a parenthesis instead of that bracket. So just be careful. I used the curly brace to start it, but then I ended it with a parenthesis, and then once I hit enter, it gave me an error. So I'm going to go back and change that parenthesis to a curly bracket. And then I get 2 and -10. So I get 2I plus a -10j. Number 7 is the same. It says let v equal to -3i minus 4j. Find a vector that's half the distance and in the same direction. So I basically want to take this vector and divide it by 2. And dividing by 2 is the same as multiplying by half. So I'm going to go back into the curly braces. I think I must use a parenthesis first, then a curly bracket. For -3i, the coefficient is -3. For -4j, the coefficient is -4. I'm going to close off the curly bracket, close off the numerator, then I'm going to divide by 2. So I get -1.5 minus 2j. Any questions about number 7? Now I use a set of parentheses because I'm forcing the order operations. I'm having it to just calculate the vectors and then divide the vector, the horizontal component and the vertical component separately by 2. All right, that's number 7. Problem number 8 says u is equal to I plus 5j, v is equal to -2 minus 4j, w is equal to 2i minus j. They want us to find 4v plus 3u. So I'm basically going to put it in the calculator. All right, so in order to put 4 times v in the calculator, I'm going to put 4, right, that's my scalar, and then I'm going to put the vector in component form in the calculator. So v is -2i minus 4j. So I'm going to put in the coefficients of -2, -4. I'm going to close off the vector by using the curly bracket. Plus 3 times vector u. So I have 3, which is my scalar. Vector u is 1, 5. Close off my vector. And we have 5i minus or plus a -1j. So the calculator makes this a little bit easy. But, okay, so 9 works about the same, right? Just put that in the calculator. But whenever you see the multiplication, you cannot multiply vectors in the calculator. Okay? So this is where we must use some formulas. Whenever you're asked to multiply vectors, you must use something called the dot product. And where is it? It's the dot product. It says the dot product of the 2 vectors u and v is denoted by u times v and is read as the dot product. So if you're talking about vectors, you never like say multiply vector u by vector v. You just refer to it as a dot product. So here's the dot product. It says the dot product of U and V, that's equal to your horizontal components multiplied, right? So you multiply your horizontal components. You would multiply your vertical components, and then you add the two together. The dot product does not give you a vector answer. The dot product gives you a single number answer. So for example, this says find the dot product of 2, 3 times 4, -1. So let me just show you what happens if you were to do that in the calculator. Okay, you're going to get something other than 5. So let's say if we have 2, 3 times 4, -1. Oops, and I must use a curly bracket. Notice I get 8, -3. What the calculator is doing is it's multiplying 2 times 4 to get 8. It's multiplying 3 times -1 to get 3. The only thing it's not doing is adding those two numbers together, right? So the dot product says you multiply your horizontal components, which the calculator does. You multiply your vertical components, which it does. But then lastly, you have to add the two together. So if you're using the calculator to multiply, just remember to take that vector that you see and you want to add those two numbers. Other than that, we're just going to use the formula. So let's take a look at an example, which is problem number 10. It says given that U is equal to 3i minus 5j and B is equal to 3i plus j, we want to find the dot product for U times B. So U is equal to 3i minus 5j. B is equal to 3i plus j. And we want to find the dot product. And let's see, this is number 10. U is equal to 3i minus 5j. B is equal to 3i plus j. Find U, the dot product of U and V. So I'm going to take U and V out of I and J form. So U is going to equal to 3, -5. B is going to equal to 3, 1. So for U times V, I'm going to multiply the horizontal components, right? 3 times 3 is 9. I'm going to multiply the vertical components. -5 times 1 is -5. And then I'm going to combine, right? 9 minus 5 is +4. So when you use the dot product, you get a single number as your answer. If you choose to use a calculator, just make sure you go the extra step and combine or add your horizontal and vertical components. Okay, so what I mean by that is, I'm just going to put this in as 3, -5 times 3, 1. Notice you get 9 and -5. If you combine those two, 9 plus -5 you're going to get 4.